Okay, let's have a look. So here we have given that function h, right? So it is a function, it's a continuous function. This has to do with the domain and the range. The graph of xh has a local minimum at a point 0 and 5. Okay, we understand local minimum, okay? State whether the following statement is true or false. And what's the statement saying? The value of h must be at least 5 for all real values of x. Okay, let's break it down. So the value of h of x. So the value of the function is the value of y. So they are saying that y must be at least 5 or more for the all real values of x. Now, you are kind of thinking, how am I supposed to solve that? Let's have a think about the two functions that we know pretty well. So let's have a think about quadratic function, and let's have a think about cubic function. So quadratic function, if we think about that, that's a parable, and the saying has a local minimum, and that will be that, and that could be 0.5. So let's consider the statement here. The value of h, so the value of y must be at least 5. And that's what will be, isn't it? Because here, if I go to my, let's say here I have the y-axis, here I'm going to have y5, isn't it? So it has to be at least 5, because all these other points are going to have a bigger value of y. Okay, so that kind of sounds okay for, quadratic function. Now let's consider a cubic function. So if I am considering a cubic function, so local minimum, that's the one here, 0 and 5. So again, let's say somewhere here I have my y-axis. No, that's not the x should be. Sorry. Okay. So again, wrong place. My apologies. I keep writing the x-axis in a wrong place. Hold on. Now I got that right. Okay. So 0 and 5, that's 0 for x and 5 here for y. Okay. Now, the problem here that the value y for this function in this place is 5, but this function will keep on going here. So if I'm looking at this value of y, it's not going to be at least 5. It's going to be, I don't know, -3, isn't it? And all those points below these are going to have different value. Isn't it? Not just 5 and above, but actually going to have less than 5, not at least 5. So meaning 5 and above, but it's going to have below 5. So that statement isn't true, isn't it? Because cubic function is showing that no, actually it's not going to be true for cubic function, isn't it? And cubic function is a continuous function. So that's what I'm saying. Even if we consider that statement based on our two function, we can figure it out that, okay, no, it's true sometimes, not true all the time. Yeah. And those are the two functions that we are very familiar with, the graphs of those two functions.